Hey y'all, welcome to Miss Clarke's chemistry class. I'm here to help you make sense of everything you've been learning in class. This lesson, I'm going to teach you how to calculate using stoichiometry and dimensional analysis. Don't let that word stoichiometry freak you out. We're going to use dimensional analysis, but I'm going to walk you through every single step. It's not going to be as scary as what people make it seem, I promise. So go get your notes, get a calculator, get a periodic table. That's right, I said calculator. We're doing math again, and you know that's my favorite. And let's get started. Stoichiometry, isn't that such a weird word? Let's talk about what that means. Let's say we're going to make a cheeseburger. And we're going to make one cheeseburger. And to make that one cheeseburger, I'm going to need 2 buns. I like 3 pickles on my cheeseburger. We need a meat. Gotta have cheese. And if I had more space, I would add bacon and make a bacon cheeseburger. But let's say I don't need to just make one cheeseburger. I need to make 500 cheeseburgers. So if my product is my 500 cheeseburgers, then I would need to use these coefficients as a mole ratio, or since we're not necessarily talking about chemistry right now, just this ratio. So for every one cheeseburger, I'm going to need 2 buns. And I could use that ratio to figure out how many buns I'm going to need for 500 cheeseburgers. Or for every one cheeseburger, I'm going to need 3 pickles. Again, I can use these ratios to figure out how many pickles 500 cheeseburgers are going to require. Because if I'm in the business of selling cheeseburgers for profit, I don't want anything to go to waste. I don't want to have to throw out extra pickles at the end of the day. All of the pickles that I buy, I want to make my money back by putting them on cheeseburgers and selling them. This process of adjusting a recipe to figure out how many more or how many less cheeseburgers we want to make, that's called stoichiometry. We use these ratios, this coefficients, we're going to call these mole ratios, because that's what they are. We could say that we need 2 moles of buns or 3 moles of pickle to equal my 1 mole of cheeseburgers. The coefficients in front, we're going to use those ratios to adjust how many supplies or ingredients or reactants we need to how many products we're trying to make. Let's work an example. Chlorine is used by textile manufacturers to bleach cloth. Excess chlorine is destroyed by its reaction with sodium thiosulfate, Na2S2O3. And then here is a balanced chemical reaction. You have to balance it first. The equation has to be balanced. And if you're not sure how to do that, click that link that just popped up. I'm here to help. Okay, so I have already balanced this equation for you because I just did not want to spend a lot of extra time on a stoichiometry video balancing chemical equations when I've already got a video created. Let's look at the actual question. Here we are. How many moles of Na2S2O3 are needed to react with 0.12 moles of chlorine? Again, we are going to use these mole ratios. For every 1 sodium thiosulfate, we would react 4 moles of chlorine and 5 moles of water. And when we react those things in those ratios, we will get 2 moles of sodium bisulfate and 8 moles of hydrochloric acid. These ratios have to stay the same. The thing is, though, we don't have 4 moles of chlorine. We only have 0.12 moles of chlorine. So, how many moles of sodium thiosulfate do we need? Now, we're going to continue using dimensional analysis. So, to use dimensional analysis, we're going to write our given. Here's our given. So, we've got 0.12 moles of chlorine. And we're solving for moles of sodium thiosulfate. So I'm going to set my problem up. Remember, whatever is given comes on bottom. So moles of chlorine on top, moles of chlorine on bottom. And I am going to repeat something so often in this video that I hope it just really becomes ingrained in your mind. This is going to be the new step. We've already talked about converting moles. This is so similar to that. But when we converted moles, we started with one compound and we just converted in that same compound. Stoichiometry, you start with one compound and you end with a different compound. So you have to use the ratio. We call this the mole ratio. And the very first time you put mole on bottom, you're going to put mole on top and you're going to change compounds because this is the mole ratio. So our given was moles of chlorine, but we need to talk about moles of sodium thiosulfate. So I put mole on bottom, I'm going to put mole on top. And when I put mole on top, I'm going to change compounds. I cannot encourage you strongly enough to not only include the unit, but to include the compound. Because in stoichiometry, you're going to change in the middle and you need to be able to keep track. The units drive dimensional analysis. And if you're not including the units, you have no driver of your problem. And it can get pretty tricky. When you have mole on top of mole, we're going to use these mole ratios or the coefficients given in our problem. In previous mole conversion videos, we always said that mole was equal to 1 because 1 mole is equal to the molar mass when we're talking about grams, and 1 mole is equal to Avogadro's number of particles, but that's not what we're using in this step. We're using the mole ratio so we can stop talking about chlorine and start talking about sodium thiosulfate. So I'm going to look at chlorine. Chlorine, 4 moles. So I'm going to put that here. That's why we need a balanced chemical equation. So if it's not balanced, that's the first thing you have to do. Then we're going to find sodium thiosulfate. There that is. There's no number in front. Remember, no number, that just means 1. All right, now our problem is set up. We were looking for moles of sodium thiosulfate. We've got moles of sodium thiosulfate on top. When you get what you're looking for on top, you are done. Put the equal sign and let's put it in the calculator. So we're going to start with our given, 0.12. And then remember, I am always going to ignore 1. So when I talk about where the next number is, I am ignoring 1s. So the next number is on bottom. And when your number's on bottom, you got to divide. So divide 4. I am going to think of sig figs. Always think of sig figs. My given has 2 sig figs, so I need 2 sig figs in my answer. My calculator is giving me 0.03, but I am going to add that last 0 so I can have 2 sig figs. Don't forget that unit, moles of sodium thiosulfate. So if we're starting with moles and going to moles, we're only going to use this mole ratio right here. So we just needed 1 conversion. Let's look at another example. Same question, same information, different question. Chlorine is still being used by textile manufacturers to bleach cloth. Excess chlorine is destroyed by its reaction with sodium thiosulfate. We already have that balanced chemical equation. So let's read our question. How many grams, so that's what we're looking for, grams of water, are required for a reaction of 0.59 moles of chlorine? So this time, we only have 0.59 moles of chlorine, but we're trying to decide how much water we're going to need for this reaction. So we are going to have to use that mole ratio, but we're going to grams, and so we're going to need an extra step. Again, dimensional analysis, always start by writing your given. So we've got 0.59 moles of chlorine. I'm going to set my problem up. Whatever is given comes on bottom. This is the first time I'm putting moles on bottom, so I'm going to put moles on top. That's the new step for stoichiometry. First time moles goes on bottom, moles goes on top, and we're going to change to our new compound. The compound in question, water. Now I have moles of water on top, and I'm looking for grams of water. I need another step. Whatever is on top comes on bottom. Now the next time mole comes up into the problem, we're going to use a conversion factor. Here is going to be a mole ratio. This is going to be a conversion factor. And since we're going to grams, we're going to put grams on top. The second time you put moles on bottom, you're going to put whatever unit you need on top. And we need grams of H2O. I kind of like to get my problem set up before I put any numbers in. So I have the structure of my problem. Let's go back and fill in the spots. So moles of water, 5 moles of water. So 5 is going to go here in our mole ratio. Moles of chlorine, we have 4 moles of chlorine. 4 is going to go in my problem. For every 4 moles of chlorine, we're going to need 5 moles of water. That's our mole ratio. That's also the bridge that takes us from chlorine to water. Okay, so now our conversion factor, we've already stated that 1 mole is equal to the molar mass when we're talking about grams. So we would need to add up 2 hydrogens and 1 oxygen. Hydrogen, if we look at the periodic table, has a mass of 1.008. I'm going to multiply that by 2. I'm just going to do that math in my head. We got 2.016. And then oxygen, we only have 1 of those, 15.999. So when I add that up, I'm going to get 18.015 grams. That is our molar mass. That goes in our problem where we wrote grams. Our moles of chlorine will cancel. Our moles of water will cancel. That leaves us with grams of water. That's what we're looking for. That's how we know it's time to put it in the calculator. Let's go back to the beginning. Type in your given first, 0.59. Now, I've got a number on top and bottom, so it really doesn't matter which one you do first. I'm going to do top. Top means times, so times 5. Bottom means divide, so divide 4. And I'm going to go over here. Remember, I'm ignoring this 1. So my last number that I need to enter it is on top. That means times 18.015 equals. I've got 2 sig figs here. And so my answer is going to be 2 sig figs. That would just be 13 grams of water. I know when you have decimals in your calculator, you really feel like you need to write them. Always go by your sig figs though. 13 grams of water. If we need to react 0.59 moles of chlorine, it's going to require 13 grams of water to do so. Are you wondering how I put that in the calculator? Here, let me write out what my calculator display shows. In the calculator, I typed in 0.59 times 5, because I'm going across right here to 5, divided by 4, because 4 is on bottom, times 18.015. I hope that helped. Especially if you were thinking, what is she doing? Okay, let's look at another example. Oh, still using the same chlorine textile manufacturers to bleach cloth. Same balanced equation, third problem. How many grams of water react if 67.3 grams of hydrochloric acid is formed? 67.3 grams of HCl, that's our given. And we're looking for how many grams of water. Our very first problem was mole to mole. Our second problem, we did mole to gram. Now we're doing gram to gram. Again, let's write our given. The process stays the same. It doesn't matter what you start with and what you're going for. Dimensional analysis will always get you where you need to go. 67.3 grams of hydrochloric acid. I'll set my problem up, and I'm not exactly for sure how long this is going to take, so I'm going to kind of just put a line. We'll add to it as we go. Whatever is on top comes on bottom. Grams of hydrochloric acid. Now, grams of hydrochloric acid, that's making me think molar mass. And remember, that's equal to 1 mole. So that's what goes on top, 1 mole of HCl. I'm going to come fill this number in a second. Mole of hydrochloric acid is on top. Nope, that's not what I'm looking for. I'm looking for grams of water. So I got to keep going. Whatever is on top comes on bottom. Mole of HCl on bottom. Oop. First time you put mole on bottom, you put mole on top, and you change to your new compound. And our new compound is H2O, water. Moles of water on top. Now, I'm getting closer because I have water, but I'm looking for grams. I don't have grams on top yet. You gotta keep going. So whatever is on top comes on bottom. Remember a second ago, I said when you put mole on bottom for the second time, you can use whatever unit you need, and we need grams of water. Okay, let's fill in all of our numbers. I'm going to start with grams of water because we just calculated that. So I don't want to calculate that again. I'm just going to look back and see that the molar mass of water is 18.015. Let's just work backwards. Moles of water, 5 moles of water. So we're going to put a 5 right here. Moles of hydrochloric acid, 8 moles of hydrochloric acid. So we're going to put an 8 right here. That's our mole ratio. That's what's bridging us from one compound to the next. And then lastly, we need the molar mass of hydrochloric acid. We need to add that up. We've got 1H, that's 1.008 if you're looking at your periodic table. Chlorine, that's 35.453. Now, our decimals might be a little different if we're using different periodic tables. Okay, so I'm going to add that molar mass up. I'm just adding that in my calculator. I don't worry about sig figs when I'm using the periodic table because I just use all of the decimal places, so my number will be as accurate as possible. And I'm going to put that in with my molar mass, 36.461. 36. All right, we're ready to put this in the calculator. Again, I'm going to start back at the beginning. 67.3 divided by, because my next number is on bottom, 36.461 times 5 because it's on top, divided by 8 because it's on bottom. And then my last number is on top, so I'm going to multiply 18.015 equals. Before I write my answer down, I'm going to come back and look at my given. 3 sig figs here. So my answer needs to have 3 sig figs. And I am getting 20.8 grams of water. When you're using stoichiometry, you can compare any of your parts of your problem. You can compare reactants to reactants. You can compare products to products, reactants to products, or products to reactants. It does not matter. It doesn't matter. Let's keep going. Oh, good. Brand new formula. I was a little bit tired of that one. Using the following equation, 2 moles of sodium hydroxide reacts with 1 mole of sulfuric acid to produce 2 moles of water and 1 mole of sodium sulfate. How many moles of water will be produced when 0.578 moles of sulfuric acid is consumed? If reading the problem is confusing you, if all of these is consumed, will produce, all of that, you really can kind of ignore that. I know, that's probably not the smartest thing for a teacher to say. Ignore the words in the word problem. But to be completely honest with you, what you really need to know is your given and what you're looking for. That's it. All of the rest is kind of just fluff, making a complete question. Don't let the extra words confuse you. So again, remember, dimensional analysis. We write our given. So we've got 0.578 moles of sulfuric acid, H2SO4. And we're looking for moles of water. Okay, so moles of sulfuric acid, that's in my given. So I got to bring it down here to the bottom to cancel out. And we just wrote mole on bottom for the first time. We got to write mole on top and change compounds. The compound we're wanting to change to water, H2O. Okay, let's look what I have on top. Moles of water. We're looking for moles of water. Yay, short problem. Let's put our equal sign and put this in the calculator. We need our mole ratio. Moles of water, we've got 2. Moles of sulfuric acid, no number, that means 1. Start with your given, 0.578 times 2. Go back and look at these sig figs. We've got 1, 2, 3 sig figs. So I'm going to write our answer with 3 sig figs. 0.116, and that would be moles of H2O. So when you're going moles to moles, all you're going to use is that mole ratio. I think that's the easiest problem, but I find my students often think it's the hardest problem because they get so used to writing so many steps that when you only have one step, you think, I must be doing something wrong. There's no way it could be this short and this easy, but it can. So remember, it's going to take some practice. Practice, practice, practice. Let's keep going. Let's use the same equation, sodium hydroxide and sulfuric acid. Let's read this new question though. How many moles of sodium sulfate will be formed if you start with 200 grams of sodium hydroxide and you have excess sulfuric acid? Again, don't let all those words bog you down. Our given, 200 grams of sodium hydroxide, and what we're looking for, moles of sodium sulfate. Let's write our given, 200 grams of sodium hydroxide. That was the NaOH. I'm going to get started, not knowing how many steps this is going to take. That is the luxury of dimensional analysis. You don't have to worry about how many steps. Let the units guide you. They'll tell you what to do. So grams of NaOH is on top. Let's bring that down. Grams of NaOH. Grams, that makes me think of molar mass, but I'm going to come back and do that molar mass in a minute. And remember, molar mass, that's equal to 1 mole. So we're going to put 1 mole of sodium hydroxide on top. Mole of sodium hydroxide. We're looking for moles. Oh, I got moles on top. But sodium sulfate, we're not done. We got to keep going. Whatever's on top comes on bottom. Moles of NaOH. And the first time you put mole on bottom, you're going to put mole on top and change compounds. Sodium sulfate. Here's sodium sulfate here. Na2SO4. Moles of sodium sulfate on top. Moles of sodium sulfate. We're done. Equal sign. Let's put these numbers in and put it in the calculator. Moles of sodium sulfate, moles of sodium sulfate, there's nothing there, that's a 1. Moles of sodium hydroxide, here is a 2, so we're going to put a 2 here for that mole ratio. Grams of NaOH, we've got to calculate our molar mass. So sodium, we have 1 of them, and its mass is 22.990 if we look at the periodic table. Oxygen, we have 1 of those, 15.999 if we're looking at the periodic table. And then hydrogen, 1.008. Let's add those together. I'm getting the molar mass to be 39.997. So that goes in our gram spot, 39.997. All right, we're ready to put this in the calculator. Start with your given, 200. Next number's on bottom, so divide. 39.997. Next number is on bottom again, so divide again. I know that makes us feel weird to put 2 divides in a row, but it's okay. Your calculator will figure it out. All right, I pushed equals. I go back. This had no decimal in it. 200. That's only 1 sig fig. So I'm going to round to 1 sig fig and get 3 moles of Na2SO4. Okay, so that's grams to moles. Using the following formula. 1 mole of lead-4 sulfate reacts with 4 moles of lithium nitrate to produce 1 mole of lead-4 nitrate and 2 moles of lithium sulfate. Let's read the question. How many grams of lead-4 sulfate is needed to produce 2.35 moles of lithium sulfate? What we're given, what we're looking for. So let's write our given. 2.35 moles of lithium sulfate. There's lithium sulfate, Li2SO4. And we're looking for grams of lead-4 sulfate. Let's keep that in mind. So whatever we start with, that's got to go on bottom. Moles of lithium sulfate. First time you put mole on bottom, you got to put mole on top. And we change compounds. Lead-4 sulfate. There it is right there. So we've got PbSO4 Again, I'm going to leave those blank and just keep setting up my problem. So we've got moles of lead-4 sulfate up top, but we're looking for grams. So I'm not done. I got to keep going. So whatever's on top comes on bottom because you got to keep everything diagonal. 1 mole of lead-4 sulfate. The second time you put mole on bottom, you put the unit you need on top. We need grams. Grams of PbSO4 Grams. We're done. Let's fill in our numbers. PbSO4 PbSO4 nothing in front, that's a 1. Lithium sulfate, here's lithium sulfate, there's a 2 in front. Grams, we've got molar mass again. Let's add that up. We're going to have 1 lead. Lead's molar mass is 207.2. We've got sulfur, but we have 2 of them. Sulfur is 32.066, and we've got oxygen. And remember, this 2 is going to distribute. That's how we have 2 sulfurs, and we're going to have 8 oxygen. Oxygen's mass is 15.999. Let's add this up real quick. So I've got 64.132, 127.992. Now I'm ready to add. So my molar mass needs to go in my problem with grams, 399.324. All right, we're ready to put this in the calculator. Start with your given, 2.35. Next number's on bottom, so divide. Next number's on top, so we multiply. And this is going to be a pretty big answer. Before I write my answer, I'm going to come back and look right here. 3 sig figs. 3 sig figs, and that gives me 469 grams of PbSO4.
Stoichiometry. It's really not that big of a deal. Everyone makes it seem like this big, scary process. But if you take it step by step, you're going to be successful. And don't forget what I always say. If you want to be successful in chemistry, you've got to keep practicing. I know you can do it. Okay, until next time. Bye, y'all.